All right, so we're back here. So let's talk a little bit about the first thing we'll talk about, and this is about significance tests for proportions. So this is really, if we're going to talk about using these data, this is mainly used for categorical data. So, hair color or religious preference or something like that, right? Where people live or high school attended or whatever, right? So there's a bunch of different categories. You guys should know these right now. So usually for these tests to work, we assume random data, whether through an experiment or a randomly collected sample. And we also want it to be pretty large for this to work. And so the way that we end up stating this, right? So if we go back into hypotheses, right? You'll recall that this is the null hypothesis, and so we'll put a little colon, and we'll say that this is equal to some value, right? And the alternative hypothesis is going to be the proportion is greater than in one way. Another way to do it, we could say, is not equal to this. So this one assumes it is positive or greater. So this is a directional hypothesis. This one is positive or negative and bidirectional because we think it could be less than a certain value or greater than. We could also state this as like this. And so we would say that this is negative direction, smaller, and again, one direction, not like the band. So that's the way that we would kind of state these hypotheses, right? So we see that this is like what the null would be. The alternative is either we're going to say it's like the proportion is actually greater than that, or it's going to be not equal to it, or less than. So when we think about this, right, we usually do the first thing. So like most problems, what we have to do is first find the standard error of the null hypothesis. And this is going to look very familiar, right? So we find the proportion value, we multiply it by its complement, we divide by the sample size, and then take the square root. So that's the first thing that we're going to do, right? So we always got to find this first. So always need this info. If we don't have this, we can't figure out the problem. And then we estimate this based off of a z-score. And the way that we figure this is that we take the proportion value, the observed one, minus the null value, so whatever we believe that's going to be, and then divide it by the standard error, right? So in this way, we're taking the observed value minus the hypothesized value, hypo is what I'll frame that here, and divide it by the standard error, right? So that's kind of what we're doing, right? And so with this z-score, we can get a p-value. And smaller ones are good. Values are good in the sense they demonstrate statistical significance. Large values equals that there is no statistical difference between the null and alternative hypotheses. So first, before doing this, right, we usually after we calculate this, we have to establish a significance level, which is usually used with the symbol alpha. And in most studies, this is 0.05, although you will also see 0.01, 0.001, and so on. These are the most common, and really, like, depending on your interpretation, they could have different values, right? But, you have to establish this beforehand. These are the most conventional, though. Most conventional. And so a lot of papers you'll read that are published have significant findings at 0.05. All right, so we'll work on a couple problems here to help solidify some of this content and material.